Hello everybody and welcome to assignment DD. This is the second page, page 308, and we're still dealing with similar triangles, and we are attempting to find unknown sides based on ratios. We're just going to do a few of these problems. Now there's 7 of them. I'm going to do about 4 of them just to show you how some of them work, and hopefully you can do the others on your own. For number 1, we need to set up a ratio that will compare all sides effectively. If we look here, 10 and 20, that's a simple ratio. That's a 1-to-2 ratio. Basically means the first triangle is exactly 1/2 the side of the size of the second triangle. So in order to figure out y, we just need to look that it goes with 35. Cut 35 in half. Y is 17.5. Same thing with x. 13 is half of x, so to find x, just multiply 13 times 2. X is 26. Okay, for number 3, we have a triangle embedded in another triangle. They are similar. We just have to set up a ratio to make a comparison. First to find, let's focus on finding x. X is this little piece right here. And we know that the other triangle here, we got isosceles triangle first of all, 36 and 36. This similar triangles, this side's 24, this side here is 24. X is not too hard at all, no ratio needed. We just take 36 minus 24, and we get 12. So that is our x. X is 12. Alright, now to find y corresponds with 36 square root of 2. Y is the smaller triangle, so we'll compare the smaller triangle to the side of the larger triangle. Y goes with 36 square root of 2, just as 24 goes with 36. Now, to make this a little bit easier to work with, we can reduce 24 and 36. That reduces to 2 over 3. So let's write this again. Y over 36 square root of 2 is equal to 2 over 3. And then we'll just crisscross multiply. 3y is equal to 2 times 36 square root of 2. That's 72 square root of 2. And then we can divide both sides by 3. 72 divided by 3 is 24. We still have that square root of 2 there. And you can leave your answer like that if you want to find the decimal. Then it comes out to 33.94. So either of those answers is fine for y. Now, number 5, we have, again, a smaller triangle embedded in a larger triangle. It's good to know the whole sides of the larger triangle. 8 and 16 make 24, so that'll help us set up ratios. Let's first find x. The x is this is the side of the smaller triangle. The larger triangle is 9 plus x. So the x corresponds to the 9 plus x side, just as the 16 corresponds with the 24 side. So we will cross multiply and solve to get that. 24x is equal to 144, and that's what we get from 16 times 9, plus 16x. And then we'll subtract 16x from both sides and get 8x. 8x equals 144. Divide both sides by 8, and we find x to be 18. Okay, let's work on finding y. That same ratio of 16 over 24 we can use. And let's reduce that to make life a little bit easier. 8 goes into 16 2 times, 8 goes into 24 3 times. It's kind of like saying the smaller triangle is 2/3 of the larger triangle. We need to set up a ratio for that. 16 goes with 24, just like a 7.2 goes with the y. Okay, cross multiplying, we get 2y. And then 7.2 times 3, we get 21.6. And then 21.6 divided by 2, we get 10.8. And that is our unknown y.